Right, so carrying on with my 6502 project, where I'm building a 6502 CPU out of Logic Gates 7400 series ICs and that kind of thing. I've got 3 new PCBs to carry on what I'm doing. So up until this point, what I've been making is basically a prototype, which has sort of worked, but got a little bit annoying because of wires hanging everywhere and power distribution problems and that sort of stuff. So I have not exactly started from scratch, but decided to look at some of the mistakes that I've made so far and work on things a little bit and rethink it a bit. So what I've done is taken the overall design of a 6502 with all its various different parts. I've sort of split it up into 8 or maybe somewhere between about 7 and 9, roughly 8 different sections. And what I'm doing is making one of these PCBs for each of the sections. So I've sort of modularized it a little bit. So let me show you these 3 that I've got here and where they fit into the overall plan and why I've done it this way. Well, let's concentrate on one of the boards. So this is the program counter. So the 6502 has got a 16-bit program counter, and I've implemented it on this board here. There's not a huge lot of complexity to a program counter. You just want to be able to store a 16-bit number, increase a 16-bit number, and get the 16-bit number back again. I've implemented it as 4 different, it's 4 74HC163s, which sit down here. So they're 4-bit counters. So there's lots of 4-bit counters, gets you 16 bits. And I've got a little bit of logic just for getting the stuff from the bus into the counters, from the counters back out to the bus, and doing a little bit of counting. And then I'm going to display the value in the program counter on some LEDs down the bottom here. So the point of these boards is that the data bus, so the 8-bit data bus, has to be available on every single board. So I've put a connector at the top, bottom, left and right of every board, and the idea is that you'll be able to get to 2 of the boards and plug them together with some kind of connector that will go between the 2, and the data bus will be able to flow through from one board to the next. So I don't have to do loads and loads of wiring to get a data bus connected up. Or you could put them that way, or you could put them that way, or you could put them that way, or however you feel like doing it. And so when you combine the boards together, you don't have to worry about the connections for the data bus, because you'll sort of get that for free. Also, I learnt my lesson that power wasn't very good on the old boards, so I was sort of daisy chaining them together. So what I've done is every single one of these has got a JST connector going here with 5 volts and ground on it, and I'm going to have a star-shaped kind of topology for the power. So every board is going to have its own individual power. I'm not daisy chaining power around from one to the next, because that's causing all sorts of problems. And also, when I connect 2 boards together with connections that are not the data bus, I'm going to use IDC cable. So this is a 10-way piece of IDC cable which I've made up, just snipped off a bit of IDC cable and put these 2 connectors on the ends, and you get 10 connectors in there. And where's a place where one of those is going to go? Here, for example, I'll have an IDC connector there. I'll be able to plug one of these in here, and then on some other board I'll just plug that into the other board. So that will connect up sort of control lines and stuff like that between boards. So let's get one of these things soldered up. Okay, nice. So this is, that didn't take too long. That's the this program counter soldered up and all the chips in. So there's a 16-bit program counter there, various different bits of circuitry for getting values in and out. Got a 10-way IDC connection here, 20-way IDC connection here, and the data bus at the top, left, bottom and right sides. So the idea being then that you could plug another board. Well, you probably wouldn't plug 2 program counter boards together, but you could plug 2 boards into each other. What I've done is I've put pins on the right hand side and the bottom. Sorry, I don't know what this is. I've put pins on the right hand side and the bottom, put sockets on the top and the left, and that way, however you plug them together, you'll get the data bus flowing through. So if you plug a card on this side, the data will flow through, the data bus flows through and out that side. From the top it flows through and out that side, etc. So it just holds them together. This is the power connector here, one of these JST connectors. So they're a bit of a funny thing because they're 2mm pitch on the pins rather than the traditional 2.5 So we can shove, so that's going to go in there, 5 volts and ground. All the controls for things like increase the program counter, store things in the program counter are going to go in here using my little my little IDC connector. So that's going to plug in there, and the output of the program counter is coming out there, and we'll see the program counter on these LEDs down the bottom. So let's plug in a bit of power and a few switches and controls and stuff and see it working. Okay, so the first thing I'm going to do is to put one of these 8-bit displays on here. So what happens is this is just going to plug onto the data bus at the top here. It's going to take an 8-bit number from the data bus and it's going to display it on this 4-digit 7-segment display here. So I made this in one of the previous video. It's an Arduino here, and it just reads the value on the data bus and turns it into decimal, so it's a bit easier to see what's going on. The second bit of equipment that I need is a way of getting a value onto the data bus so I can test what's going on with it. So I've got my terrible keyboard module that I made a while back. So this is an 8-bit keyboard that puts data in to a data bus, and I need to, unfortunately this keyboard's so stupid that it puts values directly onto the data bus without any kind of tri-state buffer. So I've put a tri-state buffer in the middle of this whopping great bit of strip board. Well, I suppose I just got it solderless breadboard. So that's going to go there. So all I've done is I've taken the 8-bit output from my Crummy keyboard, which shows up on these LEDs here. It fed it through here, somehow contrived it to go into this solderless breadboard. It goes into 74HC541, which is just an 8-bit buffer with a high impedance output, tri-state output basically, which you can switch on and off. And then I'm going to connect that up using this little contrivance here, which is going to get those 8 bits through and onto the data bus. There we go. I might need some blue tack, mightn't I? Alright, blue tack it is, and possibly a better camera angle. Okay, as ever it starts to get a little bit of a mess of wires once I connect a load of things up like this in a temporary kind of way, because what I've had to do is take this IDC connector and poke a load of wires into it to interface it back into my my 12-way key switch thingy here. So I've got all the keys down here for switching the various signals on and off for the program counter. I've got my 8-bit data bus input here, 7-segment display at the back, power supply turned on to 4.99 volts. And so so I've linked up switch 12 to publish whatever's on the keyboard onto the data bus. So there you go, 255. Let's put our old friend 129 on there. So we see that value 129 on there. Press this and we publish it onto the data bus, and it's flowing through, flows out through here. So this switch here is enabling this buffer here. It's going through the data bus on the PC board without really doing anything to it, and going to the 8-bit display. So we see whatever value we've got on the switches here.